Alright, here's a video to show you how you can use a multimeter to figure out how this little relay is actually wired. So now this is basically an electromechanical switch. So this particular one has only 5 pins on the bottom. So 2 of those are going to be for the coil, and then the other 3 are going to be for the switch. But there's nothing on the actual device itself to tell us which pins are which. So here it does say that the coil is 5 volts DC and that the contacts can handle 1 amp at 120 volts AC or 24 volts at DC. Now, it's pretty easy to figure out. Which one is which, but it might not be readily intuitive for you. So we're going to actually use the multimeter to help us figure out which is which. Now, to do that, we're going to use the ohm meter. And I've got a couple of these special micro grabbers. We're going to start with this. So basically what I'm looking for is a resistance value that's either low, open, or overloaded or infinite. So what's going to tell me is that if I find the 2 contacts that are the coil, that's going to give me, I don't know, somewhere around the 50 to 100 ohm range, probably for something about this size. If I find the contacts, so if this is 3, I'm going to assume that it's a single pole double throw. So it means that there's one switch. One of these 3 is common, and then the other is normally closed, and the other is normally open. Now, if I get the 2 pins that are normally open, then the display shouldn't change. It should show me an out of range. Now, if I grab the 2 that are closed, then that means I should get a very low resistance, probably less than an ohm. And if I get the 2 that are a coil, again, it's going to be about the 50 to 100 milliohms. So I'm just going to start with. Sometimes manufacturers put the pin off here to the side to keep it separate, to designate it that it's something. So I'm just going to go randomly here. So these aren't connected, so it could either be that this goes to the coil, or and then one of the others is the other half of the coil, or this is this and that form the normally open. So I'm going to just make contact with this one. Let's see, we got 0.1 ohm, so that's going to be the normally closed contact. So I'm going to assume that this is common, that one of these is the common, and then maybe these other 2 are the coil. So I'm just going to make sure that these are not electrically connected. So maybe this is the common, and then so that means, oops. So if that one is the common, yeah. So there's no connection between these 2, but there is a connection between these. So either this one is the common or this one's the common. So we only have these 2 pins left. So, and there's our coil. So what we've determined is that these 2 pins are the coil, and this pin, what was it? This pin in conjunction with the far one is at least the normally closed. So now then, the only thing we need to do then is actually get a 5 volt source and put a current across the contact, and then see which of these 3 actually changes. Is this the so this is the normally open, but is this the common or is this the common? So I'm gonna just click on that. Now, the polarity for the coils shouldn't matter. So if I touch this, aha. So we go that this tells me that's the normally open contact. And then this closes. So it tells me this is my common. And that's how we figure out how all the pinouts of a relay. Okay, now this is a simple momentary push button, or just a push button. Now you can see that the resistance is infinite. It's over the limit because this is a normally open. So normally open refers to in its not activated state. So if I activate it, oops, if I activate it, it closes the contact and closes the switch. And when I release it, it returns to its normally open state. Now here is a nice large switch. Now it only has 2 mechanical positions. There's no center on or center position, but underneath it's got a whole bunch of contacts. Now you can actually see the orientation of the switch goes in the direction of goes in this direction. So I wonder, my guess is that it's going to be 3 single pole double throw switches. That the middle one is probably going to be common, and the other ones are going to be the different contacts. But we can always test that because you never know. These could actually be all ganged differently. It's always good to check that. So I just put it in my vise. So if this is, we'll keep it in that position. So there it's closed, and we'll flip it in the other position. There it's open. Now we can actually see if we have any electrical connection between the various poles. I don't think we would. But you can see the only part that is electrically connected is the middle part. So none of these are electrically connected. But we always want to verify our assumption. All right. So we always want to verify our assumption that this is in fact 3 switches grouped together. So there, that's contact. If I switch it, there we have contact. And if I move it to the third one, this should be an individual. So that's connected. If I flip the switch, see that one's connected. So there, we've used the multimeter and resistance to confirm that this is a ganged 3-pole double throw switch. Now here's another push button. This isn't a momentary push button, but it's actually a latching. So you can actually see as I depress it that it stays down. So the question is, are all of these 3 connected together and all of these 3 connected together? Is this 1 switch, 2 switches, and 3 switches, or is it all 1 switch? So I'm going to assume that the depressed, the state it's in right now, is actually where it makes electrical contact. So I'm just going to put this in the vise. So first I want to determine if this one is electrically connected to that one, that one, that one, that one, or that one. Well, that's interesting. Interesting. So here we go. These two form one switch. I wonder if this is also. Yep, that's open. That's open. And these are not electrically connected. Now I'm curious if the middle ones do anything. No. So this means that the outer two are one switch, and these outer two are another switch. And they're not actually electrically connected to each other. So just go through that process to find out that this is, you can use it as one push button, or you can actually use it to switch two different things. And then the middle pins, they're just in there for mechanical support. Well, for the last one, we've got another relay. Now, this one's kind of, I think it's kind of obvious. So you've got two pins that are kind of offset from each other. Then you've got two rows of three. So my first assumption is that this is going to be the coil. The two in the middle are going to be the common pins. And one of these two pairs are going to be the normally open, and then the other two are going to be the normally closed. And I think they're also electrically isolated switches. So to test that, we can measure this. There's, yeah, so we get 271 ohms. So that is the coil. And so one of these is going to be the normally open. There's normally closed. So this is the normally closed. That's probably the normally open. We can go over to here. They're electrically isolated. Now if we click on that one, this one I think is going to be the normally closed as well. Yep, and in fact it is. And this one is also normally open. So we can go through again and test. I'm not entirely sure what the voltage on this coil is, but we're going to stick with the 5 volts. It's not really kicking in. It's probably a 12 volt coil. If not, we should get a nice little puff of smoke. Well, that could also mean that my assumption was incorrect. And actually, this is the common. Yep, that's it. And that's how you go through and deductively figure out the pinouts of a relay.